Part 2, this is for questions 7 to 10. Question 7 is coming from differential equations. The variables x and y satisfy this differential equation, where x is ranging from 0 to pi over 4. It is given that y is equal to 0 when x is equal to pi over 6. Solve the differential equation to obtain the value of x when y is equal to pi over 6. Give your answer correct to 3 decimal places. Now, the first thing, of course, we do in doing these differential equations is to separate variables. Okay, so I will say separating variables and then integrating. And integrating. So to separate variables, I will put x on one side. So I will just cross multiply, put y this side, then this x will come here. Then after we shall divide all through by cos 2x. So that means we shall have dy, and then that dy will multiply with this sine squared 3y. Then this way we shall have 4 tan 2x, then times dx, but then we shall divide all through by the cosine of 2x. Then now we can integrate. Now we know that when you differentiate, because this one can be sectan, okay, sectan, but I want to simplify something here. We know that if you see the even powers of sine and cosine, you express them in terms of the double angle for cosine. So we know that cos of, let's say, 2a, this one is equal to, in terms of sine, it is 1 minus 2 sine squared a. Now this is 2a, here we are seeing a. That means if we have, let's say, cos 4a, then, or, let me write this one here, or making sine squared a the subject of the formula. So bring this one this side, then let this one go there. We shall have sine 2 sine squared of a, then shall be equal to 1, then minus the cosine of 2a. Now we shall divide all through by 2, not so? So take this one off, and then you have that. Now, this is a, but here we have cos 2a. Now, how about this one? 3y. So that means sine squared 3y will be equal to, since this a here is doubled, then we are also going to double this one. Then we shall have 1 minus the cosine of 2 times the 3y. That will be 6y. Then out of what? 2. You see that? Now also, when you differentiate sec, let's say ax plus b, you'll get sectan. So we can have sec ax plus b, then tan of ax plus b. Okay? Then we shall also enter inside and we differentiate the angle, so we get an a here. We do that by using chain rule. So I will take, actually this a, it's better to write it here than writing it here, because it might interfere with what we are having here. Okay, so we have something like that. That means when I integrate on both sides, I can take out this a, then it will be 1 over a, like I divide it all through, then I integrate on both sides. So this a has gone. So when I do so, that means this integral will cancel with this, and then I'll have 1 over a, then sec of ax plus b, which will be the integral of sec of ax plus b, then tan of ax plus what? Plus b. You see that? So I can say the integral of this one here, the whole of this, with respect to x shall be equal to, remember this a has gone this way, so it will be 1 over a, then the secant of ax plus what? B. Now, when we come back to this one here, I will now have the integral of this one, remember, is this. So I will say 1 minus the cosine of 6y out of 2 with respect to y. Then this one will be equal to, we have a 4, I can put it outside. Then tan of 2x, 1 over cosine is sec, not so? Sec of 2x dx. Now, by comparing this one here with what we are having here, so the b here is a 0, a is a 2. You see that? So when we differentiate, what is inside here is the one that gives us this a here. So that means we shall have a 4 here, then times, we shall have a half, because a is this 2, then sec of the 2x. You see that? Then we can put plus c. And then how about this side? Of course, I'm going to put the half here. When you integrate 1 with respect to y, you will get y. And then when you integrate cosine, you get a positive sign, but there is a minus. So we shall have sine of 6y. But when you differentiate this 6y, you get a 6, so you divide it. Remember, if it is differentiation, we multiply through. If it is integration, remember it is the reverse of the integration, so we divide it. Is that clear? So what I've gotten here is the general solution, okay, without finding the arbitrary constant. Remember, the arbitrary constant, you can put it on each of the sides. Maybe this is C1, this is C2, but I can take this one this side, and then I have C2 minus C1. So a constant minus a constant, you will get another constant. The two constants are not the same, okay? So it is better you put it on one side. It doesn't matter which side you put it, but I recommend that you put it on the right side, okay? Then from there, we need to get that value of C we have gotten, but we use the initial conditions given here. So this is the general solution. Then after getting the value of C, we get what we call the particular solution, okay? So we have x is equal to pi over 6, and then y is equal to what? 0. So we have a half, then 0, and then 0 here. This one shall be equal to, this will be 2. Sec is the same as 1 over cosine. So cosine of 2, and then x is pi over 6, then plus the c, not so? And then we are going to have, of course, this one is a 0, so when this one crosses, it becomes a negative. Now, here we are going to have 60. Cos of 60 is a half, not so? So we shall have a half, that is 2 out of a half. But this is a negative when it crosses the equal signs. And that means that our C is going to be a negative what? 4. So meaning that the the particular solution is going to be, I'm going to get everything here, duplicate it here, and then where there is a C, I just write a minus what? 4. As simple as that. But then they said that we give, we find a value of x when y is pi over 6. We give the answer correct to 3 decimal places. Also, so we are supposed to look for x when y is equal to pi over 6. So put a half here, then pi over 6 minus sine of 6 times pi over 6. Then this one is out of 6, like that. Then here, of course, this one will be a 2. So I'll just write a 2 here. 2 sec of x, like that. Then we shall have 2 out of the cosine of 2x, then minus 4. So we are supposed to make x the subject of the formula, not so? Bring this on this side. We shall have a half into pi over 6 minus, this will be sine of pi. Sine of pi is 0, okay? The sine of 180 is 0. So meaning what we are having inside here is only pi over 6. You see that? Which is going to be pi over 12. So I'll just write this one as pi out of 12. Then I'll add on the 4 that is coming from this side. Then this one is equal to 2 out of the cosine of 2x. Then we can cross multiply. So we shall have cosine of 2 of x, which is equal to 2 out of now the whole of this, which is pi over 12, then plus the 4. And then we shall have 2x, which is equal to the arc cos of everything here, which is 2 out of pi over 12, then plus the 4. And then we divide through by 2. That means our x here is going to be a half of the cosine, the arc cos of 2 out of pi out of 12, then plus the 4. And they said here that the x ranges from 0 to pi over 4. That is the first quadrant. And of course, what we are having here is positive. You see that? So you just press this in the calculator and then you give your answer to how many decimal places do they want? 3 decimal places. So the calculator has to be in radians here. In fact, let me write this one here. X shall be equal to the calculator. Calculator must be in radians. Very, very important. So my calculator is already in radians. So I have 0.5, then times the arc cos of 2, then out of, we have pi out of 12, then plus the 4. Then I close the brackets. Then we shall have 0.541. 0.541. That is to 3 decimal places which they wanted. And that is that. Question 8. Let f of x be equal to this, but a express f of x in partial fractions. So this one is the first part. If they give you to express the function in partial fractions, the next part can come from integration or binomial expansions. So here we are having a linear factor, then this one is also a linear factor but repeated. So that means we shall have 3 minus 3, then x squared out of, this is 2x plus 1. And then here we have x plus 2 squared. So we shall have a out of this 2x plus 1, and then plus b. Then we consider when this one is not squared, so that is x plus 2. And then we also consider when it is what? Squared. It's like when you are dealing with this a half plus 1 over 4. You see that? But this one is the same as 1 over 2, then plus 1 over 2 squared. So we are going to find one LCM, and since 2 is in here, then we are going to have that 2 squared as the LCM. Okay, so this one here which has a square is coming from this 2 here, just like you have this and also this one here. You get that? So that is what we are having there. Now we can proceed. We are supposed to have a common denominator here, which is this one. Do not get everything. This one you also multiply in here and here. No. Just get this one. So you say this one divide by this. That means this one will go. So you remain with this, then times the a. So meaning we shall have a, then times the x plus 2 squared. You see that? Then plus the whole of this divide by this. So that means this x plus 2 will cancel with 1 here. And then you get the whole of this that is remaining times the b. So what do we have? B then times 2x plus 1 and x plus 2. Then you get this, divide by this. So of course, this one will go. We remain with this, then times the c. So we shall have plus c into 2x plus 1. Then we equate to the numerator here. Why do we equate to that numerator? Because this one has gotten the same denominator here, which I can just duplicate and put here. And also this one is just like that. You see that? Now they have the same, the same common denominator. So that means the numerators are also going to be the same. So that's why after multiplying these, we just equate to the numerator. Then you look for the values of x that you can substitute in here, such that some terms are terminated and then you remain with others. So for example, if x is equal to, I just get this one and I equate it to 0. So x is going to be a negative 2. That means this one is going to disappear. This one is going to disappear because we shall have a 0 here, is 0, and then, then we remain with this one here. Not so? So negative 2 times 2, that will be a negative 4. Then plus 1, you get a negative 3. Then of c, then is equal to, also substitute here. You have negative 2 squared. What do you get? That is negative, that is positive 4. Positive 4 times 3, that is negative 12. And then 3, okay, let me do like this. And then we have our c is going to be equal to, this is 12. So 3 minus 12, you get a negative 9. Then divide by a negative 3 here. So that means our c is going to be equal to a 3. You see that? Then we can also get another value of x. If x is equal to, we equate this one to 0, so it will be negative a half, not so. Because here when you put negative a half, it becomes a negative 1, so plus 1, that will be a 0. So meaning that this one will be terminated, and also this one will be terminated. Then we shall be remaining with this one. You get it? Now, negative a half, 2 minus a half, that one is 3 over 2. Now 3 over 2 squared, you get 9 out of, we get 9 out of 4 now of a, then which is equal to, what do we have here? We have 3 minus 3, then negative a half squared. So our a shall be equal to, this is 3 minus, this is 3 over 4. Then you get 4 times 3. You get 12. 12 minus 3, 9. So you also have 9 over 4. That means our a will be a 1 also. So 9 over 4 is equal to 9 over 4. And then a becomes a 1. Now, since the values of x that we can substitute in here to terminate the terms here are done, then we can look for any value of x. For example, if x is equal to 0, put a 0 here, you'll have 2 squared, which will be 4a. And then put a 0 here, put a 0 here, that will be 2 times 1, which is a 2, then times b. So that will be 2b. Then plus, here we shall have a c, and then this way we shall have a 3, because this one goes. Remember, we are looking for the value of b. So here 3, then our c is also 3, then 4a, then minus 4 times our a is 1. Then we divide by the 2, because this b was multiplied by a 2. So negative 4 divided by 2, what do you get? Negative 2? Yes, so b is going to be equal to negative 2. So this simply implies that your f of x is now going to be equal to, our a is a 1, so we shall have 1, then out of the 2x plus 1. Then our b is a negative 2, so we say minus 2 out of x plus 2. And then our C is a positive 3, then out of x plus 2 squared. So that is our final answer. Now you can see that for part B, it is coming from integration. I told you part A can be from partial fractions, then B can come from integration or binomial expansions. So part B, hence find the exact value of this. We are going to have now the integral for 0 f of x with respect to x. This one is going to be equal to our A, we got it as a 1. So 2x plus 1. We are integrating that with respect to x. Then I will also say minus, we shall put a 2 here. Then we are integrating 1 over x plus 2 with respect to x. And then we also have a 3. So I'll put a 3 here. And then we have x plus 2 squared. Down in the denominator, I will write it like this with respect to x. So all of these from 0 to 4, 0 to 4, 0 to 4. When I differentiate this one, I'll get a 2. But what do I do to this 2 in order to get a 1 that is above there? We are multiplying by a half. You see that? Now this operation here that I've done on my derivative to get what I have here is what I'm going to make as the coefficient of the natural log of the denominator here. So that means we shall have a half, then natural log of 2x plus 1. And then here, when I differentiate this, I get a 1 here. So that is just the natural log of x plus 2, like that. So already there was this 2 here, so I have to maintain it. And then here we have a 3. Then here we shall increase the power by 1. Then it becomes x plus 2. Then to the power of negative 1. Then divide by the new power. Then times the derivative of this one. The derivative of whatever is in here is a 1. So like that. Then we put the limits. And then we have 4, then 0. Then we can put the limits now. So you put a 4 here. 4 times 2, 8 plus 1. That one gives us a 9. So we have a half of natural log of 9. Then minus 2. Then a natural log of 4 plus 2. That will be a 6. Okay. Then from there, we shall have a negative because this one is negative 1 times the 3. So we shall have a minus 3. Then out of this one will come down as x plus 2. So you put a 4 plus the 2. That will be a 6. Not so? Then from there, we subtract. Now we put a 0. So when we put a 0 here, you'll have a half natural log of 1. But natural log of 1 is also 0. Then put a 0 here. We shall have minus 2. Then natural log of 2. Okay? And then put a 0 here. You'll have a 2 power negative 1. So we shall have a minus 3 out of a 2 here. Remember this one is a minus 3 over x plus what? 2. So now you put your 0 here. Don't you think you are having this? Okay. Then after that, of course, I'll close the brackets and better to extend this one there. Now we simplify in the format that they need here. So we shall take this one up here and it will be natural log of 9 using rules of logarithms. This is power half, then minus. This will be natural log of 6, then squared. Minus 3 out of 6. 3 out of 6, isn't that a half? Yes, that one will be a half. Then when I open the brackets here, of course, this one is a 0. So a negative and a negative, that one will be a positive. So I'll have a positive, then the natural log of 2 to the power of 2 when this one goes up here. Okay? Then a negative and a negative, that one becomes what? A positive. Then let me solve the natural logarithms together. So this one is going to be natural log of 3. I can bring this one first, which is a positive. So plus natural log of 4 then minus the natural log of 36. 6 squared is 36. Then this is 3 over 2 minus a half. 1.5 minus 0.5. Don't you get a 1? Yes, we are getting a 1. Then next here we shall have natural log of 3 times 4. 3 times 4, that is 12. Then divide by 36. Because this is a subtraction. Okay. And then this is 12. It goes into 36 how many times? 3. So we shall have 1 over 3 plus 1, not so? But then 1 over 3 is the same as 3 to the power of negative 1. That means this one can come down here. And then we shall have our final answer as 1, then minus the natural log of 3. And that is that. Because this one is in the same format as what we are told here. Our A is the 1. Then our B is a minus 1. And then the C is the 3. As simple as that. Question 9. The constant A is such that when you integrate from 0 to A, this function here, you get 1 over 8. But show that A is equal to this. Now A is expressed in terms of A. That means this one is coming from numerical solutions. So this one here is a product of two functions. If you find a product of two functions, when we are integrating, we use this acronym, ILATE. And when we are using ILATE, this one represents inverse trigonometric functions. This one is logarithmic functions. This one is algebraic functions. This one is trigonometric functions. And then this one represents exponential functions. Now, the one that comes before the other is the one you differentiate, and then the other you integrate it, okay? Because when it comes to integration by parts, one function is supposed to be differentiated, and then the other one is integrated. So this is algebraic and then exponential. So we are here and then here. So algebraic is this one, which is our x. So we shall let it to be u. So our u is going to be x. Then we differentiate that. So du dx is going to be equal to 1. And then dv dx, that's the function we are going to integrate, which is the exponential function. Okay? And we know that when you integrate e to the power of a function, you get the derivative of the function, okay? And then you divide it by that exponential function. If it is differentiation, this one, you multiply it here, okay? Now, this is integration. So, our v is going to be the integral of e to the power of negative 2x dx. Now, here, we are going to have differentiate this one here, we shall get a negative 2. So you'll get e to the power of negative 2x, then we divide by a negative what? 2. You see that? What we are having here. So meaning, now for integration by parts, we have when you integrate u dv dx, and it is even given in the list of formulae, this one is equal to uv minus the integral of v, then du dx, then with respect to x. So meaning when we are integrating from 0 to a, this x, then e to the power of negative 2x, with respect to x, we shall have our u, which is x. Then our v is this one here, which is e to the power of negative 2x out of 2. Then minus the integral of our v, which is e to the power of negative 2x out of negative 2. Then times du dx, which is a 1, then with respect to x, and then we shall put the limits here, a, then 0, and then we shall equate this one to 1 over 8. Now we proceed here. This one is going to be, but I think there is a minus here, pardon me, there's a minus here for our v here, okay? Then let us proceed. So we shall have negative x, we don't write negatives in the denominators, so I would write it like this. Then, in fact, I don't need this since I have the equal signs this other side. Then, of course, this one here, we'll multiply with that, and then we shall have a positive. So it is a half, then times, when you integrate this, we have already gotten this one, not so? So times e to the power of negative 2x, then out of negative 2. And then we have an a, then 0, then this one is equal to 1 over 8. Now we can put the limits, put a wherever there is x. So we shall get negative a, then e to the power of negative 2a out of 2, then minus, this will be 1 out of 4, then e to the power of negative 2a, and then after that, then we can say minus, now put a 0 in here, that means this one will go, and then here we shall have a minus a quarter, then e to the power of 0, then this is 1 over 8, and of course this one will be a 1. Now from here, what is common? It is a half, then e, or I can just leave it as e to the power of negative 2a is common. Then I will have negative a out of 2, then minus 1 out of 4, you see, like that. And then here we shall have a quarter, because this one is a 1, and then this is 1 over 8. Then from here, I can actually make this one as one fraction, okay? So the LCM for these two will be 4. 4 divided by 2, what do you get? You get a 2, then times this, so you get negative 2a, then of course minus 1, and then this is e to the power of negative 2a, like that. Then this one will be equal to 1 over 8, then minus 1 over 4. And of course I can say times 2 to have a common denominator. Then this will be 1 minus the 2, that will be a negative 1, then over 8. So e to the power of negative 2a, and then we have a negative 2a minus 1 out of the 4. Then this one is negative 1 out of what? 8. There are many ways I can solve this. I can multiply all through by 8, because 4 can go into 8, okay? So if I can multiply all through by 8, that means this 4 will go into 8 2 times. And then, in fact, this one, I'm going to write it as 1 out of e to the power of 2a. Then a 2 will multiply in here. And then we shall have a 2 here. Let me actually put it here. Then negative 2a minus 1. And then here we shall have negative 1. Now, if I can take out this negative 1, that means, and we can even cross multiply, we can have a negative 2, then you have, in fact, open the brackets. So we can have negative 4a, then minus 2, then is equal to negative e to the power of 2a. So when you divide all through by negative 1, everything becomes a positive. You see that? Now, based on what we are having here, that means, since I'm seeing a natural log, that means this a here, that has, this a that has, that is up here, is the one that we are making the subject. So we introduce logarithms on both sides of this equation. Then we shall have natural log of e to the power of 2a. Then using rules of logarithms, this one will come down, and then we shall have natural log of 4a plus the 2, which is equal to 2a natural log of e. But of course, you know that natural log of e is a 1. So you have 2a, which is equal to the natural log of 4a plus 2. So meaning our a is going to be a half, then the natural log of 4a plus 2. And this is exactly what they have told us to show. Part B, verify by calculation that a lies between 0.5 and 1. Now, suppose I have a graph. I'm just assuming maybe it comes like that. And at the point where it cuts the x-axis, that is what we call the root. A root is a 0 of a function, or when we substitute that value into the function, we get a 0. So a root is a 0 of a function. Now, we can see that on the left here, there is maybe an x coordinate, and also on the right of this root there is an x coordinate. But now the corresponding value, the corresponding y value of this x here, we are seeing that it is above the x-axis, so it is positive. And then the corresponding x value here, we are seeing that it is a negative here. You see that? So meaning if you're having two x values and the root is in between them, then that means one of the values must give a negative and then the other one must give a positive. So there has to be a change of sign in that function. Okay, so what we are going to have, first of all, we have our a, which is equal to a half, then the natural log of 4a, then plus what? 2. So what you can do is to either bring this one this side or this one this side, so that you get a function. So we shall have a minus a half, then the natural log of 4a plus 2, which is equal to what? 0. So that means my function in terms of a is going to be this one here, because remember, for a root, we have a function then which is equal to 0. Now, we get f of 0.5. What shall we get? Wherever there is a, we are going to put this 0.5. Okay. Then the natural log of 4 times the 0.5, then plus the 2, we get a certain value. Then we also put 1. So this will be 1, then minus, this will be a half, then the natural log of 4 times 1, then plus 2. It will also give us a value. One gives a positive, the other one gives a negative. 0.5 minus 0.5, then natural log of 4 times 0.5, what do you get? You get a 2, then plus 2, that's a 4. So we get negative 0.1931. Negative 0.1931, and the rest of those figures. Okay. Then when we come to this other one down, what do we get? So here I'm going to put a 1, then minus 0.5, then in here 4 plus 2, that will be a 6. So this one is positive 0.1041, 0.1041, and the rest of the figures. So you can see that there is a change in the signs. Then I will say, since there is a change of sign, since there is a change of signs, change of sign for, not for, I think better to say between f of 0.5 and f of 1, then I can write this one here. Therefore, a lies between 0.5 and 1. Okay, then next, part C, use an iterative formula based on the equation in A to determine A correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Now what we are going to do, since we are not given the initial approximation, I will let this initial approximation to be the average of the two values. Okay, approximation, but you can start with this one or the one, no problem. But if it is in between these two, it is better to begin from the middle. So be maybe x1, so that will be 0.5, then plus 1, then divide by 2, and then this one will be 0.75. Okay, now x2 will be equal to, you show the examiner when you are in fact this one is going to be a1, not x1. Okay, pardon me here. So this is a1, now this will be a2, which is going to be, I think there is a half, so there is a half, then the natural log of 4a. So your a you're putting there is 0.75, then plus 2, and then the answer you get here is to 4 decimal places. So what do we get? We have 0.5, then the natural log of, there is a 4, then times 0.75, because that will be a 3, then plus a 2, then close, and then we shall have 8047, 0.8047. Remember, we are writing to 4 decimal places. Then the next one, you don't need again to write this. So since you have shown the examiner that you are substituting in here, the rest you just write their values. Maybe this is A4, A5, maybe A6, or maybe even A7. So we get this one, we substitute it in the place of that 0.75. Do not go to the calculator and then you put the answer you have gotten, then substitute it here. Many times it fails, okay? Just substitute this one, you have rounded to 4 decimal places. So I will come to this one where there is 0.75, I'll put 8047. And then we get 8261, 0.8261. We continue, then I'll come back here, 8261. We have 8343, 8343. Not so? Now, when you look at this, they said we are giving our answer to 2 decimal places. So this will be 80, this is 83, this is 83, okay? Then that means maybe this is the minimum number of iterations I can do, because this one is giving me 2 values that are giving to the same degree of accuracy. Now let's check the third one. It has to confirm. So let's go and we see. We come back to this one here, then we write 8343. Then this is 8374. 8374. Now this one would have confirmed, but to 2 decimal places, this one is 84, 0.84. That means we have to continue. You see that? 8374. What does it give us? That is 8385, 0.8385. Now, when you look at this one here, it is also giving us 0.84. Okay? So, we continue. These two are giving us the same value. So, we continue and we see whether this one confirms. So, we come back to this one and we put in 8385. Then we have 8389, 0.8389. Then when you look at all of these 3 to 2 decimal places, they are giving us 0.84. So that means the value of A to 2 decimal places will be 0.84. And that is that. How do you know that you're supposed to stop? That is when you get the 3 values which are rounding to the same value that is given in the what? Based on the degree of accuracy. So 3 values are giving the same value to this degree of accuracy that they have given you. Then you stop. So that is that. Question 10. The polynomial x cubed plus 5x squared plus 3x plus 75 is noted by p of x. Part A, show that x plus 3 is a factor of p of x. So using the factor remainder theorem, where we say p of x is equal to, this is the divisor, maybe ax plus b, then times the quotient, then plus the remainder. If we get p of negative b over a, like suppose I equate this one to 0 and then I get a value of x and then I put it in the polynomial, already this one has disappeared because this is now a 0. Then you will get the remainder. Not so? Like that. So if it's a factor, then that means it has to give us a remainder of 0. So I'll put this one in here. And then we have p of negative 3 is going to be negative 3 cubed. Then plus 5. X is negative 3 squared. Then plus 31 of negative 3. And then plus the 75. And then this one must give us what? A 0. Okay. So what do we get here? we shall have this one as negative 27, then plus 9 times 5, that will be 45, then minus 93, then plus 75. Negative 27 plus 45 minus 93 plus 75, we get a 0. And the remainder has to be the what? The 0. So that is that. So I can actually conclude and say since the remainder is a 0, then x plus 3 is a factor of p of x. Then next, part B, show that z is equal to this is a root of p of z. Now, we are going to substitute in here. Then we shall need negative 1 plus 2 root of 6 of I. We shall need the square because we can see it, and then the cube. So the square is going to be, you square this one here, you will get a 1. Then this times that, we shall get negative 4 root of 6i. Then plus, now square this one here. When you square this, you get a 4. Then 4 times 6, that is 24. And then I squared. And you know that I squared is negative 1. So we shall have negative 24. Then just negative 24. Remember, I squared is equal to negative what? 1. So meaning here I'll have negative 23. Then minus 4 root of 6 of I. You see that? Then next we shall need this one here, which is cubed, and that is the same as getting this one here squared, then times when it is not squared, and so. But we have this one as this, so that is negative 23 minus 4 root of 6 of I, then times negative 1, then plus 2 root of 6 of I. Now we open the brackets to see what we get here. So what shall we get? This times this, we shall get a positive 23. Then this times the 2, that will be a 46. Then root of 6 of I. This times that, we shall get a positive 4 root of 6 of I. And then this times this, we shall get 4 times 2, that is 8. Then root of 6 times root of 6, that will be a 6. So 6 times 8, that one gives us 48. Are we there? Now this is a negative times a positive, so you get a negative. And then I times I is I squared, which I squared is negative 1. That means times the negative here, this one becomes a positive. And then this one here will give us 23 plus 48, that will be 71. Then minus, of course, minus 46 plus 4, that will be minus 42. Then root of 6 of I. Okay, now we shall have P of negative 1 plus 2 root of 6 of I. This one will be equal to the cube that we have gotten. Okay, in fact, let me say negative 1 plus 2 root of 6i cubed. And so up here, what do we have? Then plus 5x squared. So plus 5. Then this one here squared. Then what else? We have 31x plus 31, then times this one here. Remember, z has taken the place of x, okay? And then lastly 75. Yes, so plus 75. Now let's see what we are getting. This one cubed is what is here, That will be 71 minus 42 root of 6 of I, then plus 5 times this one squared is here, which is negative 23 minus 4 root of 6 of I. Then if we can open the brackets here, we shall have negative 31, then plus 62 root of 6 of I, then plus the 75. And then let us get the real part separated from the imaginary part. So we have the 71 here, then 5 times this. That one will be a negative 115. And so then there is this minus 31. Then there is this 75. That is the real part. Then we go to the imaginary part. So here we have minus 42 root of 6. Then there is 5 times the 4. That will be a minus 20 root of 6 of I. Then there is a 62 root of 6 of I. Okay. In fact, let me take off the I from here, and then I put it outside here. Of course, 75 plus 71, that is 114. No, 146. And even this one is 146, a negative, so that means we are having a 0 here. And then minus 42 root of 6 minus 20 root of 6, that will be minus 62 root of 6, and this is plus 62 root of 6. That means we shall have 0i. Okay, so in other words, we are getting a 0. So we are also getting a remainder of 0 when we substitute this one in the p of x. So that means that one is also a root. Then part C, hence find a complex number z which are roots of this pz squared. So suppose our z is equal to x plus iy. Okay, that means p of z squared shall be equal to, now we need to do some long division. Okay, now the fact that this one here is a root, no, they have talked about z squared. So if this one is a root, that means its conjugate is also a root. Are we there? Its conjugate is also a root. And also from here, they also gave us this one here, x plus 3. So removing x and then I put z, that means this z plus 3, or maybe z squared plus 3 is also a factor. So this being a cubic root, okay, then it is going to have how many roots? 3. One is real, and then the other is going to be, the other two are going to be complex conjugates. Okay, and if we are having this one, then the other one is going to be with a minus here, that is the conjugate. You see that? So this means that we are going to have z squared plus 3, because this one is being real, and then we shall also have a quadratic expression here that is coming from the other two factors, one being the other two factors which are complex conjugates of each other. So I will say z squared, then minus, okay, minus what? Let us look at what we are having here. This one is negative 1, then plus 2 root of 6, negative 1 plus 2 root of 6 of I. Then the next one is going to be minus, the conjugate of this one will be negative 1 minus 2 root of 6 of I. Okay, then we can say this one is equal to 0. So this will be the factorization. Okay, then of course I will get this one here and I will equate it to 0, not so? So z squared plus 3 shall be equal to 0. So meaning z squared is equal to negative 3. Then when you take the square root, you can have z1, which is equal to, when you get the root here, it is the same as saying root of 3 times root of negative 1. And root of negative 1 is I. So that means we are going to have root of 3, then I. But remember, when you take the square root, you have plus or minus, not so? So meaning z2 shall be equal to negative root of 3i. So those are the first two. You see that? The fact that this one is cubed, we have, it was p of x, which was a cubic root. Then wherever there is x, you are putting z squared. That means we are going to end up with z to the power of 6. You put z squared here, then you cube. You're going to have z power 6. So that means the values of z we are going to get, they must be 6. You see that? Now next, we are having z as this one here. What will be z squared? Because it is a complex number. So z squared is going to be, you square this one here. Okay, we shall get x squared, then plus 2xyi, then square this one here, it will be minus y what? Squared. Are we there? Now, z here, z squared, this is the real part, okay? So we have this one here, which is z squared minus y squared, then plus 2xy of I. This one will be equal to, we can equate this one to negative 1, then plus 2 root of 6 of I. You see? Each of the z squared. So like I'm saying, z squared is equal to this. You see that? So this root here and this root here. But this is your z squared. Now this is like finding the square root of this complex number and this complex number. As simple as that. Okay, so how do we find the square roots? We are going to equate the real parts. So x squared minus y squared is equal to negative 1, not so? And then 2xy, that is the imaginary part, then will be equal to 2 root of 6, not so? So I can solve, I can maybe put y in terms of x, the 2 will go, then we shall have root of 6 out of x. So root of 6 out of x. That implies that when we come to this one here, by the way, what did I do here? I must have this one is equal to negative 1. So we have x squared minus, then the y is root of 6 over x. We square it, then we equate to negative 1. And then from there, we have x squared minus 6 over x squared, which is equal to negative 1. We can multiply all through by x squared to eliminate this denominator. So this one will give us x to the power of 4, which is x squared squared, then minus 6, which is equal to negative x squared. And this is a quadratic in x squared. So plus this x squared minus 6, which is equal to what? 0. Then this one can be factorized. Two numbers, when I multiply them, they give me negative 6. But when I add them, they give me 1. That one has to be a positive 3 and then a negative 2. So meaning we shall have x squared plus 3. Then we also have x squared minus 2. You see that? Of course, we shall get this one here plus 3, which is equal to 0. And then you have your x here, which is equal to square root of negative 3. But here, this one is, we need real values, okay? So this is undefined. Z, which is equal to x plus iy. The x and the y have to be real values, okay? That means we shall get this one here. This is the one we are going to use to find the value of x. So therefore x is going to be plus or minus the square root of what? Of 2. Now for x which is equal to 2, okay, what is y? No, not 2. Square root of 2. What is y? Remember, y is this one here. So it is root of 6. It is root of 6, then over root of 2. And you know that root of 6 is the same as root of 2, then times root of 3, not so? Then we are dividing by root of 2. So this one will disappear. That means we shall get root of 3. Okay? Then for x, which is the negative, so I will just duplicate this. Then I put a negative, a negative, a negative here. Then this would be a negative. So that means maybe z4 will be equal to, our x is this one here. So we have root of 2. Then y is root of 3 of I. Not so? Then what else? We have z5 shall be equal to negative root of 2, then minus root of 3 I. So this one here, no. This has to be root. The other one was z1, z2. This one has to be z3, z4. So we have this one here, and also this one here. Okay, then after that we also need to do the same thing, okay, as for this other root here, this one here. So we can also say similarly, and I'm not going to do each and everything. Similarly, we have this one here. I'm going to just copy this here, then put it here, and then where there is a plus here, I put a what? A minus. You see that? Again, we equate this x squared minus y squared is equal to -1. Same equation. Then we also have 2xy is equal to -2 root of 6. And then x becomes negative root. No, I mean y. Y becomes negative root of 6 out of what? Out of x. You see that? So solving this, of course, you are going to put this one in here, and then you are going to get the same values of x, because now you are going to have x squared, okay, minus 6, okay, root of 6, it's a negative. Let me show you. So you get this, then put it in here. You have negative root of 6 over x. Then you say what? Squared. Then this one is equal to -1. When you get a negative and you square it, you are going to get a positive. So this one will come out to be like this. And when you solve that, still, you are going to get your x, which is equal to plus or minus the square root of what? 2. Are we there? Then what will be y? Your y, again, you will say, let us take this, just duplicate it and put it here. You will say for y, for x which is equal to root of 2, then y, remember there is a minus here. So a minus here, minus, and this will be a minus here. Then when this one is a minus, remember there is a minus here. So this whole thing is going to become a what? A positive. You see that? So meaning z5 is going to be equal to root of 2, then minus root of 3i. And then z6 is going to be negative root of 2, then plus root of 3i. You see that? So I will enclose this one here and then that one there. So this is what we are going to have here. In fact, let me take this one off. You put it here, and also this one, put it down here. So that is that.